Chapter 7, Example 2. Even if you hit the fast food joints for lunch, you should have a good breakfast. Nutritionists concerned about empty calories in breakfast cereals recorded facts about 77 cereals, including their calories, per serving, and sugar content in grams. How can we use sugar content to estimate calories in breakfast cereals? So we want to come up with a model for this. How can we estimate the calories? We want to write out that model that will let us do this. So I already have some information for you at the side. We have our scatter plot, which we're plotting sugar versus calories. So sugar is our explanatory variable. We're saying if you know how much sugar content, can you predict the calories? Okay, we have our mean calories and our standard deviation of calories, and we have our mean sugar and standard deviation of sugar. Don't worry about that last graph. We'll talk about that in a moment. So, what's the first thing we do? Of course, we want to describe the distribution, use DUFs, and then check our conditions. So, the scatter plot of sugar content and calories in breakfast cereals has a moderately strong positive linear association. If you said it was just strong, I would probably be fine with this. The points are spread out a little bit, but it's definitely linear. That's a pretty good one. Okay. So now let's talk about this. Okay. Both sugar content, which is in grams, and calories are quantitative variables. It doesn't hurt to go ahead and put the units in there. Okay. And the scatter plot is linear. There are no outliers. Maybe you want to consider these points outliers, but they're close enough, and we're saying moderately strong. I don't really think they're significant. With this many data points, they're not going to pull it down, so I don't really consider those outliers, and there's three of them kind of clustered together. Outliers. So I will fit a linear regression model to this data. Okay, so just as before, we're going to calculate it. I'm going to go ahead and write down the formulas again. Why? Because every time I use a formula, I like to write it down. On the AP exam and on the tests, I will give you a formula sheet. However, the better you know the formulas and understand them, the easier some of this stuff becomes. And so every time you write it down, you're getting practice with the formula, and it will eventually help you to remember it. Am I going to require you to have it memorized? No, but it will help you out if you know these formulas. So our correlation is 0.56. It's positive association. Positive correlation, that matches up. Our standard deviation of the y is 19.5, and for the x is 4.4. So we can set this simple equation up. Okay, so now we do the 2.45, we do the 107 that we have. 107.0 minus 2.450, which is our slope, which again, in our previous example, we talked about the context, so this means for every 1 gram of sugar that's added, we would expect the calories to increase by 2.45 calories. Our average calories, our mean calories are 7.0, and this equals 89.85. So now we can write a regression model out. Remember, we're not going to use y and x in this model. We're going to use the context. So calories, hat, always calories hat. If you don't have a hat, it's not a model, and your entire answer is wrong. 89.85 plus, because our slope is increasing this time, 2.450 sugar. And we don't know exactly where this goes. We could put a couple values in. Honestly, we could put in 0 grams of sugar, and we know 0 grams would start at about there, if you want, right about 90. And we could do 4 grams to see where that would get, and then put our line in. But we know it's going to start somewhere like that. So our line's going to look a little bit like that. It's not perfect. I'm just kind of doing a quick sketch on it. Actually, I think I'll make it a little lower because my slope's a little bit less than that. Something like that, probably. Good enough. You don't have to put it in here when we use technology. I definitely would. It doesn't hurt to have that illustration, but if you're going to put it in, try and make it a bit accurate. More so than what I just did. Okay, so now we need to write this up, say our final thing, but there was this other graph that I have down here, and every time you do a linear regression from here on out, if you have it provided or if you're given the raw data and you graph it yourself, I want you to check a residual plot. I'll show you how to do that on the calculator in our next example. A residual plot should look like nothing. It should be a cloud. Points should be evenly spread everywhere. There should be no pattern to it. Normally what you'll see, on the calculator at least, you'll see a line through 0. And you should have about the same amount of points above the line and the same amount of below. It should be all spread out kind of in a cloud. And that's pretty much what we have here. We have a couple points down there we might not like. It gets a little bit lower in a couple spots, but in general this is pretty good. So we're going to do that. The residual plot shows no pattern and a pretty constant spread. So I am fairly confident in the appropriateness of fitting a linear model. Okay, so the residual plot shows no pattern and a constant spread, so I'm fairly confident in the appropriateness of fitting a linear regression model. Given the amount of sugar in a cereal, we can use the model calories hat equals 89.85 plus 2.050 sugar to predict or estimate the calories of a cereal. Keeping in mind this will not be right. On average, we would expect an increase of 2.450 grams, sorry, not grams, calories for every 1 gram of sugar a cereal has. Now, according to this model, we would expect a cereal with 0 grams of sugar to start with 90 calories roughly. So that's what the y-intercept means in this case. Sometimes it has a meaning, sometimes it doesn't. In this case it does. If we had a sugar-free cereal, we would expect it to start with 90 grams. Or sorry, 90 calories.